Sweet. We're recording? All right. So let's talk about the lab. State abbreviation quiz, not the state capital quiz. And if you turn in a script, does the state capitals? I told you not to. It's not even the requirement. Stop copying garbage off the internet and turn it in and say it's yours. That bothers me. Write your own code. Like this is a safe place. This is where you want to fail. And I know that those of you that here know this, but this is where you want to make the mistakes. This is where you want to have my guidance and tell you how to get better and where to focus. The more you copy work, the worse off it is. And the more you use AI to write all your homework, I don't care if it writes some of your homework, okay? You use it. It's there. It's technology. I'll never say no. Just ask it smart questions that are relevant to our class and don't turn in code that like super programmers couldn't read or like Chat GPT just did it for you and you don't even understand any of it. Like, try to write your code and give it to Chat GPT and ask it where it would improve upon it and if you keep asking these AIs dumb questions, they're going to stay dumb. So you have to ask intellectual questions to grow the damn thing, right? And feed it more information too. So it knows how to correlate that information in a different way. You're part of the solution when you use it. But let's kick this thing's butt. So first thing I'm going to do is drag over my mainline logic from my other template. Right, I'm going to reuse a lot of code here. So I'm going to hit enter a couple times, throw this down here. I know I'm going to have to define a main function, at least one main function, right? That's in the requirements. Open, close, parentheses. Right now I'll do pass. You do not need to leave pass in here once you put code under your main function. So what I've been seeing a lot of is like stuff like this, function one, function whatever. And then you have pass still. Either comment it out or get rid of it. It doesn't need to be there. It literally does nothing. Right? It doesn't add to your code. It just abstracts from the vision. It pulls your eyes from orange to orange. Either comment it out or trash it. Not needed, right? But in this case, I'm going to leave it here until I start coding. Pass, right? So it doesn't do anything, just passes. Let's see what else we got. We got this text file of states and their abbreviations. I don't care if you ask for the state, get the abbreviation. I don't care if you ask for the abbreviation, give the state. I clarified that in class. Doesn't really bother me. I already created one earlier, so I'm just going to go ahead and pop it over here. And I'll just put it up here. Bloop. Global variable called states. It's a dictionary. That's about it. Instead of it running off one line, I just made it this. But, for the class, I'll get rid of some of these. Just for readability. Right there. Made it shorter, no big deal. Leave all 50 in there. Add the territories if you want. Some people added Puerto Rico, Guam, stuff like that. It's up to you. But leave them all there. I just shortened it for readability. I don't like it when things go way off the screen. It's kind of garbage. Right? So we know that we have to do some things with this. Let's start coding right off the rip. Not even put it in main yet. Let's start the code and get our feel for it. So we know we're going to need a correct what? A correct number, right or wrong. You could leave it as an integer, or you can make it a list, put the ones you got correct in there, or the ones, or just an integer. Either way, you could do a length on your list to get the number correct, or a length on your list wrong and get the number correct. You can make it an integer or a list. It's up to you. I'll just leave it a list this time, right? And say incorrect equals 0. So now we have our correct, our incorrect. Let's, should I use a while loop? Let me think. Yeah, sure. We'll use a while loop this time around. And we'll say running equals, and we'll say 0. So 0 is false or 1, right? Whatever it is. 1 is true. So we'll say running is true. And now we could do things like while running is equal to 1. And now we can start our coding, right? We got our logic going, we're ready to roll. What do we have to do here? Let's think about this. We want to present our user with something. Do we want to ask them for the abbreviation or to write the whole state? Personally, I always go for having the user input the least amount of information. This isn't a spelling bee. This is simply, do you know the abbreviations? I would have them type in the abbreviations. You don't have to. You can do this either by slicing or flipping your dictionary. You can call on the items and slice it and get item 1, which would be the value, right? Which would be the abbreviation. But I'm going to leave it really easy. Least amount of user interactions, usually best. For a key in, now this is right where I'm going to go to states and use keys right off the rip, open, close. So what is this going to do? This is going to query the dictionary with the keys method. And for each, I can name this anything, but I named it what it is. For each key in states, now I have the key actually in a variable called key. So I have the word Alabama primed up, right? Let's just take the first one. So let's get some input from the user. And we'll just call it user state, right? User state equals input, default is a string. And you notice I didn't build a welcome yet or anything. Directions. I'm not sure on how I want the user to play yet. I haven't thought that far in advance. Take your time, design your code. Do I want to ask the user, how many would you like to do? Those of you who made me do 50 of these, minus 1 million points. And I put that in all your comments. There's no need to have a user do 50. Ask the user, give them the opportunity to break it after every selection. Do you want to keep going? Yes or no? You know, you're in a loop. You could actually break it whenever you want, right? Or have the user go, well, how many times, and get the range or the range or the length or however many times. Only grab those amount of keys. See, you could really twist this. And as you build this, you're going to see that you may need more lists, like already asked. Because if you do random on all 50, you might have to add some logic to see if you already asked it. Or if you ask it, you remove it from your dictionary so it's no longer there. So you can't ask Ohio twice or Vermont twice or 5 times, right? There's a lot of little problems in here that a lot of you overlooked, neglected, or knew they existed, but just neglected and did the bare minimum. But, you know, a good script takes time. I know there was time off, right? Is there really ever time off, though? That's up for debate. But you could start to think about your design, right? We'll go abbreviation of, and we'll say the key. Right? We'll see how that looks. Define main pass, run main, states, all this stuff. Let's save it. Save as. Less than 6 is fine. Test 5, whatever. Let's F5 this sucker. Oh man, right off the rip. Check out what I got here. Where did I break it? Line 25. Input, enter. Up, input, enter. Expected one argument, I got 3. What'd I do wrong there? Doesn't like these, huh? Is that it? It's an input, not a print. Oh, invalid syntax. So how do you beat this? So a lot of people will start throwing around single quotes. Totally fine. Totally doable, right? Think single quotes will matter? Invalid syntax. What is the big kicker here? What doesn't it like about this? Anybody know? Why did that work? Now, when you see it, when you take a look at it, doesn't look that great. You come in here, add your spaces, and now you have your Alabama. Why did these work? I know this is a couple folks been having problems with this. Let's take a look. Built-in function, prompt, read string from standard input. Let's make this big. New line, prompt string, give input output. It doesn't show me those plus signs anywhere. Is there more to this than meets the eye? Perhaps. What if we went to the docs? Let's do site python.org or docs.python.org, right? Let me make myself retype that because I can't type it all. Docs.python.org. What is it? It's likely you're adding a parameter to the rest of the string. I like how that sounds. And we'll say input. Built-in functions, input and output. Let's say input with plus sign. Pretty much expressions input. Input must have the following form. Take a look at this. Take a look at this. Interactive input, editing history, file input, interactive edit. We'll check out these two, see what they got here. This is pretty gross looking. That is garbage looking, isn't it? That's a horrible website. Find a plus sign. Ooh, plus votes. Let's see if we can find it. So they're there, but we don't have any explanation yet of why they're there, right? The end R plus opens a file for both the reading and writing mode arguments. Okay, so the R is optional, but that's not what we're looking for, right? That's just for the type. Pretty strange. Is it one of those unwritten things that input takes plus signs to separate a variable and a string? I know it's documented somewhere, and eventually we'll find it. But that is how you get around that. That's my whole point of this. So, got your string, individual. Now, if I remove these plus signs, like we already said, we're going to get a syntax error. The minute we start throwing these parameters, or these like Olivia stated, the parameter, it loves it, and everything is beautiful. Everything is how it should be. Cool. So now we have user state prompting the proper state name. It wants the abbreviation. This will hold the abbreviation. So where do we go from here? How do I got someone coming in? How do I validate that the abbreviation is good to go? Well, it's a comparison operator because I'm going to compare the user input to the actual value of the key, right? So you can say if, and we could say state dot upper open close. Let's see. Do I want to call it that? It's user state. So if user state, we make it go upper, right? And this is what I'm going to say is equal to. I'm going to call on my dictionary. Now, what I'm going to do is, you remember how to call on the key by its name, which I'm going to use the word key, but let's make this K. It might be easier to read. So let's read this. For Alabama in my state's keys, enter the abbreviation of Alabama if the user input upper is equal to states Alabama, which will return back AL. That should be comparison, right? Well, if it equals one another, the user got it right. So we're going to say correct plus equals 1, right? We're going to add 1 to our correct list. And then we can give them a nice little message saying print, you are correct. It is. And then you could say whatever you want here. It is, and then you can do states.key. Right? I think this should do the trick. So let's give it a try. Save, F5, AL, Alabama. You are correct. It is AL. Enter the abbreviation for Alaska. So I did states.key, but you are correct. It is AL. Let's give them 4, and then we could say K. Because now it'll say it is AL for the state name, right? Let's give that a try. Save, F5. This is one way to do this, right? Literally, there's 10,000 million ways to do this. Great, I broke it. It's already executing a command. So now we have you are correct. It is AL for Alabama. That goes on right to Alaska. We didn't do anything if I'm wrong yet, right? So now here comes our elif statement or else. You can do an elif, and you can say if not equal to, then an else for a catch-all. But you're either going to be right or wrong here. So there's no need for an elif, right? You go straight to else. No need to compare because you're either going to be right or you're going to be wrong. So simplifying your code, when you say it out loud and talk about it, or when you think about it, or just the more you code, the easier it gets. You learn how to simplify when to write more logic, when not to, what is it necessary, what is it, it comes in time, so don't be angry at yourself. The more you code, the better you get at it. Print, you are incorrect. You're incorrect. So we'll just leave it at that. Now, we're supposed to tell back the user what they got wrong. You could either create a list up here and pass it to the list, append to a list, and then at the end, read out the list, or you could tell them they got it incorrect in line. So you could say, you're incorrect. The correct answer is, now here we're calling for, what are we calling for? Same thing. Right? So you're giving the user some kind of feedback. They know that they got it right or wrong. It's helpful, right? So let's test this. Let's get it wrong. So as abbreviation for Alabama, I'm going to say DD. You're incorrect. The correct answer is AL for Alabama. Cool. We're educating the user as we're going. Alaska, AK, got that one right. Arizona, AR. Arkansas, AK. California is DD again. Got that. Now you notice I'm stuck answering it until I'm done. Not my favorite. And you notice it's back up to Florida, Virginia, Washington. How do I get out of this while loop, right? So that's stuck in a while loop. How do I present them a chance to keep going or not to? What's one possible way? What could I do here?
You could measure the use state input or like put a print statement and say you can stop at any time by entering a phrase. So like stop and then put an if statement. If input equals stop, stop the code or stop the while loop.
I like that. To add in logic. What if I don't want to ask them first though? Because that would give them the ability to start the game and quit right away. But I really want them to nudge. I want them to try that first one. Right? So where would I put that in this code to not give them the ability to quit right away? It might be there under the hood, but they don't know it. I didn't tell them yet. Or do I want to ask them in the beginning, how many would you like to do?
Yeah, if that were the case, then you would base it off of a range. You could do the range of your whole entire list. You could do the range of their input, that kind of thing.
Yeah, so these are just different, and we're not going to code them all. We're just going to talk about them because, like you said, you could say right here a print statement right underneath this line. Here's the rules, XYZ, enter the abbreviation, counters will go up, blah, 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 enter quit anytime you want, right? Perfect. There's nothing wrong with that. You could add logic here, a quick if statement to say elif user state equals quit, then break, right? Then you're done. There's all kinds of fun stuff you could do. You can get out of this loop any way you want. Now, there's a lot of design things I left up to everybody, and I was really surprised at how many folks made me do all 50 because you chose not to design your code and let the code run you. You made me do all 50, which I only did one right and I got the rest wrong because I don't, just testing your code.
Yeah, I made you do all 50, and it was annoying when I was coding it. I was like, man,
Yeah.
let me get through all these stupid things so I can
Yeah.
test my redo logic.
Yeah. So you can either give user the opportunity to quit with elif, right, and break plus break. Now here comes a big or, right? Or you could ask user how many times, range that in a nested for, right? How many times? How many states would you like to guess? 6. Okay, for each item in my range of length of 6, right? Because then underneath that for loop, you could do your import random. You could import random up here. You could import your random and then just randomly grab certain ones. But now you run into that logic part of what if you grab the same one twice? So it would behoove you to generate a list of keys, make your random choices from your list, and then when you choose an item from your newly created list, you pop it. So in your for loop, it's gone. So you don't have to worry about how do I deal with calling on duplicates. You don't have to because you popped it from your list. That's one way to do it, right? Another way is adding it to a new list called selected or the same list and doing a check to see if it's already in there. If in my list, don't grab, go again, random again. But then you have the potential of wasting CPU cycles checking your how random you really are because you might hit Ohio 9 times in a row. You see what I'm saying? So there's a lot of different ways you can code this after this. This is the most difficult part, I think, is dealing with the keys and the values. Where you want to take it from here, it's really up to you. It's a design thing. Um, Here we told them their wrong answer and right answer right away. You could add them to lists and then get the length of the list for the number correct or number wrong, and then present the list back to them. That's fine too. You know, I wouldn't just go print my list, then say, you got these correct. Here's my list. I would do a for loop for each item and for each correct state in my correct list. Print, you've got this correct. You've got this correct, right? Make it look clean. You can do all kinds of fun stuff, but this was the most difficult part, in my opinion. A lot of folks did some really cool stuff with calling on the items. They called on states.items and they put key value right here. Key value. So when they called on items here, the key went into K and the value went into V. And then they just did their checks based off K and V. That was slick. Really cool. Unfortunately, about, I think, 32 people did that with the same names on the same line in the same scripts. So it was really kind of fishy on how you came up to do that. But if you thought about it on your own, you pulled that off. Excellent job. If you read about it on the internet and shared it with all your buddies, good job too. Good looking out, right? I'm not mad at you. You learned something. But understand the code that you write. Understand the code that I'm not going to say copy, because hopefully you do type it. What I'm saying is what I've always said: borrow ideas, not code, right? There's nothing wrong with reading someone else's code, understanding the logic, and going, man, I can do that, right? Now, what are you really doing when you read someone else's code and you understand their logic? What is that called? Like their logic as a whole, like it does these steps in order. That's called. It starts with an A, ends with the rhythm. What is it? What does people call that? It's my alias hacker name. Go rhythm. Ah, it's horrible, right? It's a dad joke. But you can borrow these things, but it wasn't ready. Gotcha. Just focus, read the code, understand the code. Let me read this out loud, right? We're just going to read what we already scripted. Import random. We imported the whole thing. Guess what? In my head. Gore. Yeah. There we go. So import random. We define our dictionary as states. Here we just have the state full name as the key and the abbreviation as the value. Got some empty variables here, correct and incorrect. Those are going to be our counters. And our running equals 1. We're going to use that for a while loop. Not my favorite, but it seems to be something of choice that a lot of people like to do. And now we're just going to go for the gusto. We're going to see if it works before we make it pretty. While running equals 1, for, say it out loud, for Alabama, in my states, ask the user for input. Please enter the abbreviation for Alabama. If they put in AL, now you're going to say, if AL is equal to AL, then you're correct. You're going to add 1 to correct, and you're going to print, it is Alabama for AL. Cool. Inverse for the incorrect. If they're wrong, if it's not AL, you're going to get your incorrect, and so on and so forth. We discussed a couple ways how to break out of the loop, giving the user a chance to insert quit, add an elif statement right here, or maybe an else, depending on how you want to write your code, or you might want to do your if not equal to, states, catch it first. It's up to you. A lot of folks like to catch the wrong things first. I go here or there. It depends on how I'm thinking that day. It really doesn't matter. But this is the basics of it. And then, turn this into something decent. You just go, oh man, I'm not even going to deal with this. I'm just going to grab this. Oh man, look at that. Jeez, hitting the wrong keys. So get rid of this. Get rid of that. Select all this. Tab it over. Clean it up a little bit. Now you have your some of the bulk, your scripting statement. underneath your function, mainline logic, it's all good to go. You could also throw in a try except here. Some people were putting try except at little tiny areas. Awesome. Not mad at it. That'll set you up for proper logging, which is a separate module, import logging. But you, in this scenario, it's very minimal. Your syntax is correct. You don't have to catch those errors. You could do a try and accept. If something goes wrong here, and even to make this better, you could drag and drop your play again function that you've already written in multiple different lessons. While you're done, if they hit quit, I go, are you sure? Do you want to play again? Ag them on to play again. You could do all kinds of fun stuff with this. You're limited by your imagination at this point. And I know it gets a little harder to discern some of these technical, these more complex data types, like a dictionary, but it's a key value pair. Once you master a key value pair, JSON will be really easy to deal with because JSON is a dictionary of dictionaries. So, and all the same methods work there too, like in, for, all that fun stuff, right? But this is the gist of it, right? I didn't give away everything, Olivia, but at the end of the day, this is the gist of it. This is a good solid core of it. And how you want to make it look pretty and functional, that's all pre-lesson 6 stuff. Have at it. Really, really take the time. If you did a great lesson 5, you could use that for your bones. Build your great lesson 6, lesson 7. Use it in lesson. What you use in lesson 6, use in lesson 7, and your final. Pretty much cut and paste into your final. You'll be done. It's not that bad. But yeah, we'll call that it for now. We'll call that good enough. We'll call that a 5 out of 10. Right? Still missing a lot of fun stuff. Definitely put a welcome in there. Don't just prompt the user with what's the abbreviation of Alabama. Like, hi, welcome to the state game. Would you like to play? Yes. Turn this running into while if yes equals 1 and then while running equals 1. Use some logic there. Start to really build a good bones of how it would really work. Do you want to do this? Yes. Here's the directions. You can quit at any time. Here we go. 1, 2, 3. You still want to go? Yes or no? 1, 2, 3. Still want to? You see, like, frame it out, picture it in your mind. Take the time to do that. A lot of you just use the break to have beyond break, which is fine. That's what it's designed to do. Coming back to work and logic, a lot of you rush through it. That's okay. I get it, but learn from your mistakes. Give yourself more time to be as awesome as you want to be, right? But that's cool, right? That's fun for now. Let's guys, any questions on that, or any wild things that you thought we could pivot into, or
Are you about to use a return statement to stop the while loop?
You could use a what statement?
A return statement, like to stop the while loop. I tried it.
A return statement will not stop a while loop because a return statement is designed to return something from a function.
Okay.
Yep. A little different.
Thank
no
you.
problem. Yep. Break is your best friend, or controlling it like while running equals 1. Ask them if they want to keep going, change running to 0, and then it'll break the loop too. Those are pretty fun things to bust up, right? We check lesson 7. Let's get going. So yeah, it's fun. Good questions. Fun times. This lesson is awesome. And I mean this, from lesson 4 to lesson 4, 1, 2, and 3 are kind of like, okay, we're getting going. This lesson is pretty awesome. So I don't know if you guys caught this or not, but you learn the basics, the first three lessons. We go to functions, build your own reusable code. We go back to strings. We learn how to manipulate an object on the smallest scale. Then we move into bigger objects. lists, tuples, and dictionaries. Everything we've learned applies to those. And now we're moving forward into files, which are nothing more than lists, tuples, and dictionaries of strings, which is data, right? So this lesson is like where it starts to all come together and be like, oh man, I can create data now and read data and pull data in and do things. But yeah, this is where the power comes. And this whole class, I've been using analogies like when your boss gives you a list of IPs or host names or usernames or patches. You're not going to sit there and open the file and scroll down in Word. You're going to open it inside of Python, take it in, do whatever logic you want to do with that data, and then be done with it. Perform whatever activities you want. This is where it all comes together. We're going to learn how to input files, output files, using loops to process files. What that means is, and this is pretty important that I need you to understand this as much as you possibly can right now, this evening, right? Rewatch this part of the video. I don't know how many minutes it is into it because it doesn't have a counter on my side. I should start one of those. The important thing is when you open a file in Notepad, you first start Notepad, which is a process. Then you click open or hit Control-O. And then you find the file you want, double click on it or hit open. That gives the application Notepad permission to access your file and then open the file. But there's an extra step. Open the file is just accessing the information. Then it presents it to the screen. That's for usability, right? For readability. You always don't have to open it and put it to the screen. That's the awesome thing about scripting. You don't need to see everything. If you know what's already in there, you can just process the data and be done with it. Notepad, word processing stuff, Excel, all those GUI interfaces, they're there for people who can't script to use it in a graphical interface. They're amazing. People could do amazing things with them. They have for years. But you could do more without them, faster. You could bulk process things. Yes, people could write macros in Excel, but at that point, they're writing small scripts, in my opinion. So just learn Python, right? But there's a lot to this. And we're going to talk about some databases, I think, later on, but we'll talk about those next week. Pickle and the DB module. The DB module does some cool stuff for you. Pickle is great too. It's all in memory. Doing large pickles and large databases in memory used to be frowned upon, but now it's like, okay, everybody has 16 gigs of RAM. Who cares, right? But just you could do it. You could do it pretty efficiently too if you're asking the right questions, only storing a certain amount of data. You can transfer databases around quicker, and what you gain with that is a minor layer of security because some of the databases in Python and Pickle kind of obfuscate the data. They don't encrypt, they don't encode. They kind of like obfuscate it so it's difficult to read. I'm not going to call it security. I'm not going to call it encryption because it's not. But it's definitely a layer that you get with better than sending a text file in plain text across a network, right? Because those packets can be grabbed, replayed, and they have your text file in plain text, right? Oh, by the way, packets are also. Anybody take networking 101, networking 1001, I think it's called 1002 or something? Anybody take that? No? No networking, folks? I am. Cool. Take what? Like a networking class. Networking concepts, something I have. Cool. You guys do packet captures and look at packets, PCAPs? Yeah, Wireshark. Well, what if I told you, well, Wireshark has a console version called T-Shark that is way better. It's the same thing, really, without the GUI. But there is also something, you can also script T-Shark inside of Python. And you can script on its own too. You can also script something called Scapy, SCAPY. It's designed to read packet captures. So if you guys ever open up a real large packet capture in Wireshark, you're like, Wireshark, packet capture, you wait there for 2 days. You know, you're loading a 2 gig file, you sit there and wait forever. You're like, oh, geez, right? Well, it has to open that file, get permissions, open the file, present it to the GUI, and that takes a long time. Scapy, you don't have to do that. You do it right from Python, reads the file in, processes the data, finds what you're looking for, generates output for you really quickly. So think of all these graphical user interfaces that you use, except take away the graphics, and you could do everything under the hood in a script 10, 20, 30, 40 times faster, maybe even hundreds, if not thousands. I prove it every day at work. I use Scapy pretty much. Rip through packet PCAPs every day at work, and goons are just starting Wireshark. By the time Wireshark loads their stuff, I'm already done. I'm already like, it's not in there. Like, how do you know? I'm like, oh well, here I'll show you again for the 10th time, right? But there's a lot of power in messing with files, like working with files, not messing. We don't mess, right? Let me see where I'm at here. Let me do that. Get rid of this one. Get rid of that too. So let's take a look at here. So this particular, I'm going to share a couple things with you. Lesson 7. It's kind of messy, but we'll look at it. So there's a function called open. Open. Guess what it does? It opens a file. In this directory, where this script called lesson 7 notes py, in this directory, there is a file called words. It's 1.1 meg or 1100 kilobytes in size. Let's open it. Oh, sure, save it. So let's see what we got here. I opened it. I stuck it in file in or fin, right? Print file in. It's a input output. That's what IO is. That's what .io. You guys see a lot of new Web 3.0 websites like that are IT related, and there's no .com. It's a .io. Anyway, it's input output, right? Draw input output. Yep. So text wrapper, text input output wrapper. The name is words.text. Default mode, we're going to learn how to change that. Default mode is read mode. The encoding is CP1252. This we'll talk about later, but just it's default, right? So now we have the length of stuff. I have, or do we print stuff? No, we just define stuff. I print stuff. I get the length of stuff, which is how many items? Well, 3, you're right. And then I'm going to print the length of the file. Well, I get an error here in the length of the file. Why do I get a length? Input has no length. How come a text wrapper has no length? This goes back to my explaining how Notepad opens a file. It opened it. It did nothing more than have access to the file. The next thing you gotta do is read it, right? So open does just that. It's step 1. It opens the file, right? So let's take a look at this. So now we're going to do the same thing. I'm going to open words, set a counter to 0. I'm going to say for each line in my file, add 1 to the counter. Tell me how many lines there are. Cool. So it opened the file, did not read anything in yet. It just basically said for each item in my file, add 1 to the counter. What this does, this simple tiny for loop, which it says for each line. I called the variable what it is. And every hard return, it goes to the next line. Because a hard return is a new line. Yeah, so now it's all making sense from the print, right? So there are this many lines, 113,809 lines in this file at 1.1 meg, right? So that's kind of cool, right? You could open up, now we're dealing with text files or raw files, right? This will work with a lot of CSV files, text files, some basic text, not TXT, but text, raw text file types. This won't work well with PDFs because PDFs are ran through some algorithm and they're kind of obfuscated, right? So now we can count the lines really quick. Inwalks read line. So files are a type of object. They are an input-output wrapper, right? They have a method called read line. Read line, singular. And here we go. So we open the document, we call in the document, call out a read line, gives us the first line, gives us the second line, third line, fourth line, fifth line, sixth line. Default between print is a new line. That's why you're getting these empty spaces between your lines. So that's how you read individual lines starting at the top, going down. Okay, we're getting somewhere, right? So this kind of cleans things up a little bit. Everything you've learned in lesson 5 works here. Open the file, read the line, right? So now we read the line, stored it in a variable called line, and now we strip the data, that we strip any spaces in the beginning or end, store it in Word, and then we print Word. So if you do this, it just removed the spaces. There's no spaces there. And there wasn't, but strip is just, we're just proving a point that you can remove leading spaces and end spaces if there were some. Well, can we do that now? Yeah, let's try it, right? So what am I going to do? I'm going to go ahead and open this file. And we'll see if this works. I'll drag it. I'll put a space here. I'll put a space there. I'll save it. I'll close it. I'll go back to here. And those spaces are not there. Pretty cool, right? Yeah. Okay, we prove it strip works. So we know that that works from lesson 5, and we could use it when we open a file and read in a line. So now we're going to open this again. For each line in my file, word, line, strip, print the word. Watch how big this is. Remember, there's 113,809 lines. I'm not going to go through them all. But that's how you remove those spaces, by stripping the hard return from the end of the line. Cool, right? So what's old is new again. What's lesson 5 is new again, right? So now we're going to store the lines in a list. Okay, I like this. And then you could, I shorten the list. So words 2, where'd that go? Boop, 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 boop. Words 2 is only 1 kilobyte, right? So what does that mean? That means that I shortened the list a lot, right? From 1.1 meg to 1 kilobyte. Let's take a look at this. So
Maybe
we're going to, say again?
so probably 100 words or less.
Yeah, you're about right. Check this out. New method, read lines, plural. Now, I didn't give it any parameter, so it's going to read the entire file in to words2. And I'm going to print words2. Then I'm going to print the list of words2. And then I'm going to print the indice of 13. So it opened words2, didn't do anything. It read all the lines into words2. I print words2. Each line is an item in a list followed by a hard return. From what you know about lists, could you rip through this list real quick? Could you go in? Could you say, is Al, A-L-L, is Al in my list? Yes, literally, is Al in my list? Yes, true, right? Super fast. You can look for data that way. It's awesome. You could, and we never opened the file. Like physically open it in a graphical user interface. Told Python to open it, read all the lines in, for each line in lines, do this, or is this in my list? Quick answers, fast answers. It'll take you longer to open up Notepad and open up the file you want. Hit Control F. You're already done. You see the speed here? What I'm trying to instill in you, right? I mean, how many of you do this? So I always have a shell window up, either if I'm in Linux or Windows, and you could type Notepad and it'll open. You could type Calc and it'll open. You gotta spell it right. It popped up on my other screen, but you get the gist of it, right? Like these are known commands stored in an environment variable that you could call on anywhere to open them. So what's wrong with doing this? Cool. Open whatever file you want, rock and roll right here. Exit Python when you're done. You're going to see over time when you get good with it. If you give yourself the chance to get good with it, like practice with it, you'll never open Notepad again. You'll live in VI, Nano, or Notepad, or the shell itself, or Python with open and with. So if you Control F, then you will open the file automatically. No, Control F is a find. So let's do this. Let's do Notepad F, file open, or Control O, right? We'll go to this lesson. I'll open up words2, Control F, A-L. It took me forever to do that, right? Why? I didn't graphically have to see it. I just needed if it says yes or no, true or false. We'll get to that in a minute, but it's a heck of a lot faster just using Python. The red pill. Yep, you got it, Logan. Take them all. Take them both. So here we print our words from read lines. Read lines, it's important you remember that it gives you a list. Now, if these are big lines that are forever long, you're going to get that. And it's going to be a massive list, right? We'll learn some techniques how to cut those up later on. And then you got your length of words, which is 15. So there's basically 15 lines in this particular document. And when I call on the list in indice 13, it gives me AAS, which if we count them, this is indice 13. Well, but it says it has 15 things. You're right. 0, stopping at 14, is 15 items. And when we call on 13, that's exactly what that is. Everything we've learned up until now works with text from files. Pretty cool stuff. Let's count the characters. So we're going to open words2. We're going to read it. Ooh, read. So we covered read line, read lines, And now read. We're going to read in the entire file, store it in words, get the length of it, and then we're going to do some fun slicing. I think I broke it. What is running on my machine that's bogging this thing down? Let's take a look. Doo-ba-doo-ba-doo-ba-doo-ba-doo. Don't need that. Don't need that. Closing all kinds of stuff. CPU's cranking. Zoom. Of course, Zoom is cranking. Interesting. That thing popped hot pretty good. So let me turn this off over here.
Oh, really quick.
Yeah.
I noticed in the book, thin was like what they said is like the standardized object or variable to
File
open.
in. It's short for file in.
Okay.
Yeah.
Is that something we'll always use? We could technically name it anything.
Whatever you want. Whatever
Yeah.
you want. Standardization of how you do things though, like file in, file out, it helps you like long term, like create good things. You know what I mean? Like it keeps your mind right. Like every time I open a file, I call it file in. Good, checkmate. You know, I never deviate from that. You see, so it's continuity in how you code. Yeah, it's pretty cool. But yeah, you get it. Cool. I kind of freed up some memory on my machine. Had a bunch of stuff running. But let's take a look at this, right? So we're going to open up Words 2. It's just available to Python. It knows of it as an input-output text wrapper. It's going to read it, store that file in words. I'll make it the length of words. I get 98. And I say 3 to 20. Well, let's open up Words 2 and take a look at it. So if you count all these characters, there's 98 characters. And when you slice 3 to 20, 0, 1, 2, hard return, there's our 20. So you can get extremely granular if you know your data sets well. A lot of CSVs have this weird first line. It's like a backslash exclamation or a hashtag and some weird stuff. If you know it's a CSV file and you know it has that file in it or that line in it, you just read past it, tell it to skip it. You do all kinds of fun stuff. But that's read lines, read line, and read and open. You kind of understand what open does. It makes that file, first off, your permissions are good, it's open, but it doesn't do anything with it yet. It's just sitting there with the file open in memory. It hasn't even like read the data in or anything. It's just open. That's pretty hard for a lot of normal Windows folks, people who are like powerhouse Windows users, to wrap their mind around, because they're so used to Windows doing everything for you, right? I just did it there too. File open, right? So let's take a look at this. So this just gets more and more exciting. Get rid of this. So guess what? Starts with works. Starts with, we used before. It's a method for strings. You guessed it, it works awesome in files. So here we have a file called mbox text. This is an old mail exchange file, 6.6 meg. Pretty big, right? We got the entire dictionary in 1.1 megabyte, coming at 113,000 lines. And this is a 6.6 meg, just of a couple minutes of email traffic. It's just a log, right? So we're going to open that file. We're going to say for each line in my file, if the line starts with from, print the line. How cool is this? Oh, there you go. It worked exactly as expected. It has the hard return after the line. It's gross. Well, how are we going to clean it up? Glad you asked. In walk strip. Same thing. Open the file for each line, except we're going to strip the line, store it back in line. If starts with from. Now we removed all those nasty lines, right? Cool. We could also output this to another file. So now we can create data from data saying this is just the froms. Might be helpful, right? Let's take a look at this. This gets more and more fun. So now we're going to skip uninteresting lines. Well, what do we deem uninteresting, right? We're going to open the file for each line, strip the spaces. If not line starts with from, continue, else print the line. So if line not starts with, if that line starts with from, continue, else print the line. What do you think? What do you think it did there? Following? It's the continue that gets you, right? So keep in mind, you could not things and then continue and print them out inversely. Super handy. This is probably more beneficial. Here we're going to open up the mailbox. We're going to set a counter to 0. For each line in my file, strip it, remove those hard returns and the spaces. Here comes the method of find. And here we're looking for a domain. Remember, if find equals a -1, that means it didn't find it. Remember, find gives you back either a 0 or a -1. So here we're saying, if find returns back, if this equals a -1, continue, else print the line. Right now, we didn't add anything to the counter. We will. So here we go, printing the line that everything that has that domain in it. And now let's add it to the counter and print the counter. Rip through all 6.6 meg. Might take a while. Might take way too long. Not that bad. 6.6 meg. 408 from lines. Or no, my bad. 408 lines with that domain in it. What if that domain is known to be prone for sending phishing? That might be good to know, right? Something like this could be real quick to script up. If you're looking for a specific user and the domain, you could do it opposite. You could do anything you want. But what do you think of? This is important here. Find in, which is super powerful, and starts with. Cool stuff. I think it's cool stuff. No, I'm just kidding. So let's check out the next one, right? So this is pretty down dirty. So here you can start to write small little scripts. Enter the file name. Like you could tell a user to, hey, this does X, Y, and Z. Please enter the file name that you'd want to read in. Does everybody know the difference between an absolute path and a relative path? An absolute path is, say, I'll show you.
I know the difference between an absolute and a symbolic
Oh,
way
symbolic
of,
link. Woo. Yeah. Okay. Let's not talk about those yet. Good with the Logan. So an absolute path is if you were to type out C:\user Z Wojton blah 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 blah. Right? Yeah, I agree. But some people, when it comes to scripting these things, they're used to clicking on them and not typing them. Right? So an absolute path is the entire directory traversal to include the drive letter, directory traversal of where that file is to include the file name. Right? Now, a relative path is like how I've just been typing mbox text because my script is in the relative location of that file. Python looks in the current directory for that object type first. So I don't have to print out everything because the script itself and the file I'm communicating with exist in the same directory. Does that make sense for relative? I'll take silence as a yes. We'll move on from there though, right? So let's take a look at this. We're going to prompt the user enter a file name. We're going to open the file name, got our counter. We're going to strip the lines. We're going to start with, see if the lines not starts with subject. Add 1 to our counter, and we're going to count how many lines have subject in it. Mbox txt, I think, right? Hit enter, and just like that, 1,700 lines in my mbox text start with that are subjects. So that tells me that there's 1,792 pieces of mail with a subject parameter. Doesn't tell me if it's the same message, same user, same message from 14 different people. It doesn't tell me any of that, but it tells me that there's 1,797 subject lines. Pretty cool. This is just with the mailbox thing, you know. Let's go number 4. This gets fun. And build on build, right? This is what we do. Put this down here. I always forget where to put the spaces in this one. And I actually wrote this too. It's funny. Okay, so when you use the function of open, let's talk about this. What do you think it does? It'll attempt to open the file if it exists in that relative path or the absolute path, right? If it does not exist, it will create it, right? So here, as you see, I do not have a classes output.txt file. I'm going to open classes output.txt in write mode. That's the second parameter of open. Okay, save it. It ran, it printed F out, told me that the name is in write mode, everything's good to go. But now you see it's created and it has 0 kilobytes. It's empty, right? Kind of cool. So open will create a file if it doesn't exist. Be careful because you run the chance of overwriting a file if you have a script open that's already using this file and didn't close it yet, and you run the script again, it'll create the file overwriting what your other script just did if you didn't close it. Be careful. There's certain modes you write it in. This is write, there's append. We're going to talk about all those different modes. Right? This gets pretty fun. So let's take a look at this. So here we have the write method. So now we're going to open a file and we're going to write to it. What are we going to write to it? Well, strings, variables. Here we have line 1. This here's the waddle, right? More Body Python stuff. We're going to F out, write line 1, call line 2, enable it. We're going to write line 2, and then we're going to do something. We're going to close the file. Well, I'm going to close this. I'm going to start a new one. I'm going to undo this over here, and we're going to run it from the beginning. Because what this is going to do, is going to create the file, open it in write mode, print out the input wrapper, then write line 1, write line 2, and then close the file. But you'll never see the file open to the screen. Open and close are relative to Python. Python is the parent process that calls on this text file to open the object, perform tasks at whatever level, in this case it's write, and then when it's done, we're going to close it. Let's go ahead and do that. Boom, boom. So we get this, and this is just this print F out. And now you see that the size is 1 kilobyte. And when we open it, our line 1 and line 2. Writes to it in order. It appends to the bottom. Right? Cool stuff. Well, we got more, right? There's more to it. Let's do this. So now we're going to have a list. New line between item 1 and item 2. There's 0 and 1. We're going to open classes output 2. Doesn't exist. Write lines method. Guess what write lines does? It takes objects with more than one line and writes them to their proper space, their lines. And then we're going to close the file. Done, right? That was done super fast. You can't even open Notepad that fast. And here we have our line 1 hard return, line 2, line 3. No hard return, no space, no nothing. This is where those fancy things that we learned in lesson 5, like delimiter, adding spaces, adding dashes, kind of like you're in code, decode, comes in handy. If you want to leave it all on one line, you can add a comma, add a dash, all kinds of fun stuff. Let's check this out. So here, what we got going? We're going to open this. Now, I'm going to have this file open, right? I'm going to have this file open right here. I'm going to have a couple panes open. I'm going to save this, try to run it. And you noticed that it did not error out. I have it open in Windows, but Python was able to access that file and print it too, because I'm the same user. If a different user had that open from a file share or this machine, there'll be an issue. But I'm the same user, right? Keep that in mind. It's always best practice to close a file when you're done with it. So here we open the file, and we said for each line in the file out, print the line. And this is what we got. Cool. So we proved that we could create a new file, write to it, have a text strings that are in variables, and then write multiple lines or individual lines to a file. We're kicking butt, right? Check this out. We're going to append. Appending does just that. It adds to the end. This will create a file called append.txt. Let's go ahead and delete it if it already exists. And it does. So here we go. It's going to create this file, open it in append mode, print that it's a input-output wrapper. We're going to store this in a variable, and we're going to write lines. Let's do this a bunch of times. Right? And then we're going to close the file. Done. File's done. We got append 1 kilobyte, and it printed as many times as we put that line there. Cool. Super handy. So appending adds to the end. Now let's add another line to that file. We're going to open that file in append mode. We're going to go ahead and add an I'm okay to the bottom and close it. Let me get rid of this because that'll cause a problem. Open close. Before you can even say open close, it's done. And you see that it added to the end. Amazingly handy. What if, I used to do this all the time. I used to admin a ton of servers, and some of them weren't that reliable. Some of them were notorious for running out of disk space, just because of the nature of the beast of what they were. I'd run a command every 4 hours, and I'd write to a text file on a shared drive. Fine, 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 fine. 90%, 95%. Then it would break, right? But when it wrote fine, I also wrote the time, right? So think of how important that is. That's very low rent monitoring of a server. But I was able to monitor a disk space just by doing that check and writing it to a file. So when people say, oh, I can't monitor that, I call BS every time. There's so many different ways you can monitor servers. You don't need expensive, lavish tools to do it decent, right? But these little things you could use as an admin. You could use as a cybersecurity analyst guy. You can go, hey, show me all the files that are bigger. You can check the size of a file. You can check if it exists, which we'll get to coming up, right? If a file exists, which is logic, right? If the file exists, perform the action. If not, don't. Where are we at here? So we're at number 5. There's a lot to cover. There really is. But don't worry about it, because we're going to cover the rest of it next week. It'll be a blast. Oh, what's this? This is this is pickles. I don't want to get into this next week. I don't want to get into this right now. We already did 4, right? We did. Writing files, listen dictionaries. Oh no, we didn't. We didn't do this one, did we? Yeah, and I'm okay. We already did that. Cool. So we ripped through the files methods, which are good. That should be pretty good for now. But they're really not that bad, are they? Like, without looking ahead at any particular database, like a pickle or a database, think of just what we've done with these text files. Open, create it if it doesn't exist, right? That's pretty cool. Append mode, read it, read lines, read. Oh, I said read already. Then once we open it, what can we do? We could write lines, write line. So we could create new data. Pretty cool. Do you think this could have helped in your rock, paper, scissors? You could create other files of how many wins and keep a log of who played. Like when you ask for someone's name, you could write that out to a file, and if they won or lost, keep it in a log. Yeah. You think you could use it in your last project? Do the same thing? Who plays? How long it took them to play? If you put a sleep timer or a timer in your script, you could go, okay, it took Susie 22 minutes to answer all 50. It took Billy 18 seconds, so he's probably using ChatGPT, right? Like, you could do all kinds of stuff. I mean, why not? Facebook, Snapchat, and Instagram and TikTok are logging everything you do. Why not write a log? And they're selling it for money. But I don't know. How does everybody feel about files right now? You think about them in a different way now? That they're just objects? Just a type of object. Nothing more than strings. And depending on how you open it and read it in, it'll give you a list, a tuple, stuff like that. It's not that bad. Trying to take the sting out of it, Let's see what else we got to do here. Files are awesome. Now let me tell you one key pro tip about files. You're going to do this lesson, and then you're going to start to do things out in the real world. And you're like, man, I can't read any of this stuff. Well, it's important to understand file types. And I don't know how many of you live with file types, but .pys are just normal plain text. PYMs are Python module files. PYs are mostly called module files as well, because you can load them as a module. Text files are just that, plain text files, right? .dat files are usually text. No, maybe not. Maybe DAT files are encoded, right? So now you start to get in these weird data files. That's what a DAT file is, data usually. It's usually done by a pickle, which we'll talk about, or a database as well. But you'll see these different file types, .csv files, comma separated value files. Lab 7, I'll try to open a World Series file. It says I can't open it because the file doesn't exist. Are you using relative paths or the absolute path? That's the problem. That's my guess. If you saved it in the same place where you saved your script, you could just use the name of the file, the relative name of the file. If you saved it like on your D drive and your script is on your C users, you have to go D:, then the name of the World Series file, if that helps. But good thing to bring up, right? Always good. So let's run through this lesson again, see what we got going on. So we talked about most of the things. We talked about data. I don't want to overwhelm you with databases. And plus, I'm going to spend time on them next week because there's a lot of cool things you could do with them. And there's a lot of cool things that current programs on your system that are doing with them that you don't even know. They're super cool. So let's see, I got a challenge. Just not really worried about that. Group activity. It's just a list of integers again. We'll knock this out next week in no prep time. Take it and we'll write it out somewhere. So the lab is World Series. See if they won, see if they didn't. So read in a file, turn it into a dictionary. That would be pro tip, right? Click on open the file. It looks all clean here, right? Looks like team year. Stops at 2016. Go ahead. I'll update this. But let's download it. Can I download it? I think I have to go into weird mode. I think I have to go into a different mode. I'm not even bother. I have it already. It's that type of time of night where I'm like, it's been a long day for everybody, right? Let's see, World Series. Now when you open it, you're gonna have all these spaces, but don't worry, we learned how to strip, right? Open it, read it in, strip all the spaces, strip it first. So it removes all these. You're gonna have a team called No Winner, right? Maybe something big was going on in 1904. Maybe there wasn't enough teams or something, or a war or something, right? So you can polish up your data by using, not by going in here and hitting return. You could use strip, and you could use everything that we've learned in lesson 5 to clean this up. And pro tip, remember how he wrote the word brontosaurus with a dictionary? Remember that? We counted the letters, counted the characters from brontosaurus. Could you do that with this? Read lines for each line in lines. If line starts with is what? Alpha. If line is alpha, add it to a dictionary. Check if it's in it first. And if it's in it, you could add the year to it or add a count to how many they're there. Pretty cool. You can create a list of lists. You can create a dictionary with values. You could do whatever you want. You could do all kinds of cool stuff once you get data. That's my point, right? You could turn this into different objects inside of Python after you open the file and perform all your logic on your new objects in memory to get the answers you're looking for. That's the goal, right? And to do it efficiently and quickly and script it so you could use it again on like data. Isn't that awesome? We'll rip through it. There's something I'm missing because I feel like I'm missing something. I'm probably not though. But it's huge. You could read entire books within reason with memory. You could do all kinds of fun stuff. But that's basically all I wanted to go over tonight. Is just get you excited about files, opening them, reading them, understand the modes, read, write, append, and then storing them in variables, file in, file out, read lines, call them what they are, right? What do you think? This is an exciting lesson. It really is, because this is where you could combine everything we've ever learned and create a masterpiece. Has anybody checked out Python and LLMs yet? Large language models or AI? They all, every single one of them has a Python library. And lesson 8, probably lesson 8, I'll show you a bot I've been building, a standalone bot on my own machine. LangChain's awesome, but all of these are automation with Python and a large language model. So AI at scale, entry-level gateway machine learning, and even hardcore machine learning and artificial intelligence. Python is right there. Just letting you know. And large language models are nothing. Well, I'm gonna simplify it. It's a vectorized string set. So fancy terms for it's a lot of known words, right? And how they compare with each other. But that's all Python based as well. Yes, there are other languages that work just as good, if not better, but Python is the one that is easy to use, as you've learned through this course, and really adaptable to other, we'll call them disciplines. Because one discipline, I use it every day in cybersecurity. I use it for system automation. I use it for system administration. I use it for operations. I use it for cybersecurity tasks. And I also use it to mess with some machine learning and some AI in its infancy. But it's all because everything you do is an object. And as long as you know what type of object you're dealing with at that time, you know what methods you could perform on that object. Cool stuff. Yeah, that's all I have for tonight. I'm going to go ahead and stop the recording. Boop.